Okay, good morning again, everyone.
Hello, sir.
How are you?
Yeah, I'm good.
Good. Now, so in keeping with this module's alignment with the web app development module, today I want to talk about web API testing because that's what you're doing. You're doing web API development in the other module. And so I'm going to look at the testing of web APIs. So you'll find the slides for today's lecture here, back in the automated testing section. Actually, we know a lot about what I'm going to cover today already, so that's kind of good in the sense that the tool set that I'm going to be using for web API testing is our friends Mocha and Chai, and we'll be adding a third one to it. So it's web API testing now, as I would have mentioned when I started talking about testing in the outset. The old kind of testing phases were unit testing, integration testing, system testing. In the case of web app development, anyway, we still talk about unit testing, but instead of integration testing, we tend to talk about API testing. And instead of system testing, we talk about end-to-end testing. Just to be sure now people can hear me clearly, okay?
Yeah, we can hear you.
Right, so API testing is kind of the equivalent of integration testing, stroke subsystem testing. Let's not get too hung up on the terminology though. We know what we're talking about here in terms of what's the target of our testing. The target is the web API, which could really include the database as well, because the web API is going to be talking to a database. So that entire kind of subsystem is the target of our testing. So yeah, the API is the target, but kind of we're assuming that maybe there's a database behind that. We are treating the web API as a black box. That's the term I used when I was talking about end-to-end testing. What the black box entails this time is, well, our web API has an interface, that being the set of endpoints that it presents to the outside world. And it also has specification for those endpoints. So in other words, in the case of the movies API, the movies API has, let's say, a get endpoint to /API/movies. That's one of its endpoints. And we know what that endpoint should return back to us in a response. It should return an array of movies, I think, as its response. Now, from a testing point of view, that's all we need to know about the that particular endpoint. How do we invoke the endpoint and what does it return back to us? We don't care about the internal workings of the endpoint code. Hence, we're treating it as a black box. So our focus again is on what the API does, not how it does it. And again, we can, well, the fact that the API is going to be talking to a database or even possibly some other web API service, then that may be part of our concern when we're writing our tests. The testing principles are all the exact same as before. So we know about all of these things. We're still concerned with maybe what might be considered normal boundary and error cases for our particular API endpoint. The error cases would be if and when the endpoint is meant to return something other than a status 200 error response code. So the obvious ones would be a 404, 404. That's, of course, if our API implementation allows for the possibility of returning a 404 error, status error. And so if it does, then we should make sure that we test that it does return the 404 status when it should. The boundary really relates to possibly a post request to an API, where the post would include the data that we want to add to our database. And maybe some parts of that data has boundaries associated with particular properties. It doesn't really arise in the case of the movies API, but it might in other cases. Normal then would be when we do normal kind of API requests, and it returns back the 200 status with whatever accompanying data that comes with that. Given when then is what we use to kind of design our test cases to come up with the different test cases. Test isolation, we know what that means. Test target there, I'm saying we should test the target state as well as the response. So our web API returns a response, which includes a status code, a body, and maybe some other headers, but also maybe the particular API endpoint should have carried out some change to the database, because the database really represents the state in this case. And as part of our test, we should check to make sure that it did actually make the appropriate database change. The last one then, the silent principle, we know what that relates to. Now, in terms of expressing expectations in our API testing code, these are just some of the kind of things that we might be stating expectations about. The first one there, we want to be able to express whether the API returned the right status code or not. Did it? We may actually be interested in particular response, HTTP response headers that comes back from the API. Is there an easy way of expressing expectations about particular response headers? It should be easy for us to do that. Number 3 there is the actual structure of the response body. What we expected is the schema. What we expected is the actual values within that schema, what we expected, and so on down there. So it's slightly different in terms of the expectations that we would like to be able to express, and therefore hopefully the tools that we will use will make it easy for us to express expectations along these lines. Now, of course, if you are testing a web API, then by implication, there is an asynchronous nature to the target of that you're testing, which wasn't the case when we were doing unit testing. It was the case actually when we were doing end-to-end testing, as it turns out, but it's certainly the case here. The target, which is the web API, that is not going to respond back to our requests immediately. It's going to respond sometime in the future because it's coming across a network. Therefore, we just need to be aware of that, and hopefully the tool set that we will use will account for that. And I'll explain what I mean by that in a moment. Sorry, my slides won't go on. Now, we are going to be using Mocha, which is good, but there are 1 or 2 aspects of Mocha that we need to be aware of. The first thing there I'm saying is that if in a Mocha test, you actually have no expectation statements, then by default, that test will pass, which kind of makes sense, I suppose. If you're not stating any expectations, then it can't fail really, because there are no expectations. So it's expectations that cause a Mocha test to fail. So if we don't have any, then it would make sense that the test would actually pass. So that's not a surprise, but the next one, it would be a surprise, I think. So if you've got an asynchronous target, if what you're testing is asynchronous in nature, and really by asynchronous, we mean that the target does not respond immediately to any request that we make to it. That's all asynchronous means. Then I'm posing the question, does the following little example pass or fail? Now, whenever we're talking about asynchronous, then to simulate asynchronicity, we often use the inbuilt JavaScript set timeout function, which I'm sure you've seen before. So all I'm doing here is I have an expectation statement here, but it's buried inside an invocation of the JavaScript set timeout. So clearly this expectation statement is not going to execute immediately. In my case, it's going to execute 400 milliseconds in the future, if you like. So that's the body of my test case. It's wrapped inside my it block here and my describe block. So effectively, this expectation is kind of asynchronous. It's going to execute sometime in the future. It's not going to execute immediately, or it's not going to execute synchronously. Now, what am I actually doing? I'm testing to see, is the foo variable equal to true? And up here, I have set foo to false. So I would expect that test case to fail because my expectation is going to fail. But the problem is it's not going to fail. It's actually going to pass. And the reason it's going to pass is because by default, Mocha doesn't really support asynchronous targets. So Mocha is going to run through this test. And when it gets to the end of it, it realizes, well, I didn't have any expectation statement that executed. Therefore, this test is going to pass. Because I said at the top here, if you've no expectations, or at least if Mocha doesn't execute any expectations, then by default, that test is going to pass. And in this case, it's not going to execute this in time. Mocha is actually going to report on this test before this expectation statement executes. It doesn't wait for this expectation statement to execute. It doesn't wait for the timeout to complete, if you like. So the problem is that Mocha does not wait for any kind of asynchronous code within your test by default. But of course, we can actually get it to wait, or if we program it properly. And there's a way of doing that using a special kind of callback function. But the default behavior anyway is this: it doesn't wait. Therefore, expectations, well, another way of thinking about it is that the expectations are evaluated after the Mocha reports back to us. Okay, and that's what happens on the previous slide there. The actual Mocha reported back to us as to the outcome of the test. In other words, it outputted stuff to the console. But after it did that, then the expectation statement executed. Of course, it resulted in a false, but it was too late now because Mocha has already reported back to us what the outcome of the test was. That's the default behavior. How do we get it to do? How do we get it to wait for the actual expectations, the asynchronous expectation statements to execute? And this is how we do it here. Now, so the callback function that you pass to the it block, it can receive an argument, and this argument is actually supplied by Mocha itself. It doesn't really matter what you call the argument. the convention is to call the argument done. So this done argument is actually passed into our callback function by Mocha. And what done is a function. And what Mocha will do is it will wait until that function has been called before it reports on the outcome of the overall test. And you can see here that I'm calling the done function after the expectation. And I've just said that Mocha is going to wait until this function is called, until the done function is called, before it reports on the outcome of the test. And so that's really what we want, because now this is going to execute and it's going to fail. And done then is effectively telling Mocha, you can now report on the overall outcome of the tests. And so it's going to report back properly to us. It's going to say, well, the test failed because this expectation failed, which is what we wanted. Over here, I've got just kind of the opposite of it. Okay, I've set foo to true. I'm evaluating is foo true. But again, I'm using the done callback function to delay the reporting by Mocha until this actually executes. So this test is going to pass, which we would expect. This test is going to fail, which is what we would expect, all because of this special little done function provided to us by Mocha. Just simple illustration of it. I have the code, even though, I mean, the explanation hopefully is clear enough. So sample 1 is the one we were just looking at on the slides. Set foo to false. Evaluate is foo true. So this test should fail. And we're using, oh no, that's the wrong one. Do I have a sample? Oh yeah, this is just illustrating the fact that this test should fail, but in fact it passes because I'm not using done at all. So if I just run sample 1, again, it should pass, it should fail because I'm checking is foo true, and it's not because I've set it to false. But yet when I run it, you can see it's passed here. Okay, I'm getting some extra errors coming, but the errors are actually coming from the expectation statement, because that actually executes, as I've said, that executes after Mocha has reported on the outcome of the tests. So it's telling me your tests are fine, but we can clearly see they shouldn't be fine. That's sample 1. Sample 2 then is where we bring in the done special little function, as you see here and here. So now again, I'm evaluating is foo true, and it's not, it's false. So this test should fail in the kind of normal Mocha failure. So if I run sample 2, test is failing this time, which is what I expected. I'm getting this kind of ugly stuff at the end, but I can ignore that for now. And just to see that it passes when it should pass, if I set this to true, then, it's passing nice and cleanly for me. So that's this special done callback provided by Mocha. It allows us to test asynchronous code properly. The next thing is that Mocha has a timeout beyond which it won't wait for, you see in the previous slide there, I'm getting Mocha to wait for the asynchronous code to execute, but it doesn't wait forever. It has a timeout, and if the asynchronous code doesn't execute before the timeout has expired, then it will automatically cause the test to fail. So what I'm showing you here is the exact same as what I had on the previous slide. Notice though that I've got a 4,000 millisecond delay on my set timeout. So this code here is not going to run until 400 milliseconds have elapsed. And I suppose I can show you really. That's sample 3, I think. Yeah, so there's sample 3. And again, foo, it doesn't really matter about foo being false or true, because this is delayed by 400 milliseconds. The default timeout for Mocha is 2000 milliseconds. So the 4000 goes beyond that. And so Mocha is just going to complain. It's just going to say, my timeout has been exceeded by the particular test case. It's waiting, and then eventually I get my, you can see I can get my timeout error. So whenever you see this timeout error, then that should trigger that the problem really isn't necessarily your test, a particular expectation has failed. It's because you are testing a very slow target, if you like. Now, of course, you can't change the target if the target is a web API and it happens to be a slow web API. You can't really change that from a testing point of view. So what you can change though is Mocha's timeout limit. And so to do that, so the default I think is 2000 milliseconds, but we can change it. Now I'm doing it here in the package.json, but you could do it from the command line as well. So as long as I go beyond the 4000, it should be okay. And now okay, it's passing. Should it have passed? Sample 3. It's false, and I'm evaluating the false. So yeah, the test should have passed, and it did pass. So the done, callback, and the timeout are just two aspects of Mocha that you need to be aware of when you're testing asynchronous targets. Right, so as you have seen, we can still use Mocha for testing asynchronous targets. We can still use Chai for expressing our expectations. Now, in terms of communicating with an actual web API or an actual HTTP target, there are any number of third-party libraries that I could have picked. I'm using one called SuperTest, but there are many others. In fact, to be quite honest, we could have really used Cypress to do our web API testing, but I just decided to switch back to Mocha because I think you would see Mocha plus Chai plus in another third-party library in any kind of blogs that you would read. So I've just chosen SuperTest, but as I said, there are many other alternatives. And so what SuperTest is is essentially a HTTP client, so it allows you to make calls to HTTP targets, but as well, it has some expectation syntax associated with it, which are specifically targeted for testing web APIs, and we'll see those in a second. So that's our kind of tool set, if you like, our tool suite. And really how we use it is pretty straightforward, I think. So here's an excerpt from a test. So you just import the actual SuperTest library. Now you have to import the web API itself, okay? Now I'm actually importing it here using the old style of importing in JavaScript. I don't know if you've seen this before or not. Up to now, any importing we have done has been using the ES6 import syntax, which is what you're seeing here. Okay, so here I'm importing a third-party library, but we've used this import statement for importing our own code as well in the React world, and indeed in the web API stuff that Frank is doing with you. But prior to ES6, we still had modularization, and we still wanted to be able to import modules. So this is how we did it. So there was just a special function called require. That's all require is. It's a function. You give it the path name to the thing that you want to import. In my case, it's going to be the path name to the Express server that I would have written. Okay, so I have to import that into my test. And then to use the SuperTest library, this is how we use it here, because that's what we're actually getting from SuperTest, a special function called request. So request, you pass it a reference to the web API that you've imported up here. And effectively what this does is it goes looking for the web API server. If it's not running, it will actually start it up. So you don't have to start the web API separately before you run your tests. This will do it automatically for you. And then I'm just chaining on some other methods onto it. So what the get method does is it simulates sending a HTTP GET request to this particular endpoint for this server. The set allows us to set HTTP request headers if you want to. Looks like here I want to set the accept HTTP request header to this value. I'm assuming you're familiar with HTTP request and response headers. And here is an example of the expectation syntax that's available from SuperTest. And you can probably guess what I'm checking here is, did the particular endpoint, this endpoint, did it return a 200 status code? Now, the end method is where we can actually do some more fine-grained expectation analysis, because presumably we want to be able to investigate, was the body of the response that came back from the web API, was it what we expected? And where you would put that kind of code is inside here. So the end method takes two arguments. Sorry, it takes one argument, which is a callback. The callback receives either the error response from the web API or the normal response that we got back from the web API. This is the important one for us. So this is going to contain the body of the response that came back from the web API. And so presumably inside here, we are going to be writing expectation statements using the chai library this time to discover, does the body contain what we expect it to? So for example, in the case of a GET request to the API/movies, then inside here, we would check that we got the right movies back from the web API. And you'll see this in the lab. All I'm saying here is that this argument, the argument that you give to the request, it could actually be a URL, which it isn't in our case, but it could be if we had the API deployed to some hosting server. So it can be URL, it can be a reference to an Express app, which it is in our case. It could even be a normal HTTP server. So it's quite flexible. This is how we would do a post request using SuperTest. So again, same kind of flow: request, the reference to the actual web API. In this case, I'm using the post method. So that really tells SuperTest that it should construct a HTTP post request to this endpoint. The send method is where we provide the actual data that we want to include in the post. So we would have some sort of JavaScript object here representing the data. So this might be an actual movie object. Well, it would be in our case because that's the endpoint that we're posting to. Here we're checking, well, I think the way Frank wrote the web API, when we send a post request to the movies API, it returns a 201 response code. So we're checking, did it do that? And yet again, presumably there is a body as well contained in the response that comes back from the web API, and we would want to check what is actually in the body. Is it what we expected it to be? Okay, so we've kind of gone over this, right? So these are the expectation options available to us from SuperTest. And really what we would tend to be doing here is checking the status code, checking what I'm doing here is checking a particular response, HTTP response header, this one here. If there were cookies being returned by the web API, then you could check that the cookies were what you expected them to be. So that's typically what you have here. Whereas these expectation statements, these are using the Chai library. And again, you'll see this in the lab. But this is normal Chai stuff, which we've seen before. So I'm just digging into the actual response body. And the response body, in this case, because I'm sending a GET request to API/movies, the response body is going to be an array of movies. And that's really what I'm doing here. I'm checking, is it an array? What's the length of the array? That kind of stuff. Sometimes the response from a web API is something very simple or straightforward. And so if that is the case, then essentially, if I go back, you can leave out the end clause completely. Typically, if you're getting some sort of an error response back from the web API, there's no actual body in the error response of work anyway. And so I'm illustrating here by supposing I do a GET request to a particular movie where 9999 is not a valid movie ID, then that should return a 404 status code, and the body of the response just contains some sort of error message. So I'm using SuperTest's own expectation syntax to evaluate this. But of course, we're back to the problem of asynchronous. Because it's an asynchronous endpoint, I'm using my done callback function here. So I do still have to call the done function to tell Mocha to wait until all of these expectation statements have been evaluated. And of course, they can't be evaluated until the actual response comes back from the web API, which is sometime in the future. So I still need that little bit of code there. Now, Frank, in the web app dev module, has covered the promises programming style for coding asynchronous communication code, and SuperTest actually supports the promises programming model. And I think really the promises programming model is cleaner than the one that we've seen up to now. The one involving using the done callback, it's okay, but it's a bit long-winded. So this is how you would program SuperTest using the promises model, and there's just a few small little changes. The code really looks very like the code that we've seen so far, as in if we compare that code to this code, this is using the done callback, as I mentioned. Okay, we're not using the done callback here. What we need to do though is we need to return whatever request returns. If I could do a compare and contrast, if I go back to the previous slide, I don't have any return statement here, whereas I do here. It's very subtle. What we're returning actually is a promise, because that's what the request function returns. It returns back a promise. The rest then is the same, except this bit here. And you're familiar with the then clause when you are writing promise-based code. So as you know, anything inside the then function, which is all this stuff here, that is not going to execute until this particular promise has completed or resolved. And of course, what does that mean? It means that this promise will only be resolved when the web API responds back with its response. And that's what we want. We don't want this to execute until the promise has been resolved. So that's the promise-based programming model using SuperTest. And as I said, it's the one that we would see used most often, really. Here's the promise-based programming model implementation when the response back from the web API is something like a 404 error and there's only a simple body. Okay, so there's no, I don't need the then clause here at all for this case. I could still use it if I wanted to, but it's just slightly less coding involved. But this is only really useful when the body of the response is something very simple, which if I go back, it wouldn't be in this case because the body is going to be an array of movies, and presumably you want to make a number of expectation statements about that array. Whereas here the response is a simple object with a key value pair, and we're just checking are the key value pairs what I expected it to be. Now, Mocha has been around for quite a while, and it predates ES6. Indeed, the Node platform predates ES6 as well. And there is one part of your implementation that causes problems for Mocha and indeed Node. And it's a fairly fundamental part of ES6 syntax that both of those platforms don't understand. And it turns out to be that Mocha doesn't actually understand these import statements, and neither does Node, as it turns out. Okay, we like writing them because we like writing modern JavaScript, i.e. ES6 plus JavaScript, but Mocha doesn't actually understand them. What Mocha understands is the old style importing syntax. This old style is technically referred to as the Common JS model. Common JS was a library that was developed a number of years ago to allow us to modularize our JavaScript code. And this is the most frequently used part of Common JS. And we've seen this earlier in the lecture. So this line here is the exact same as this. However, Mocha doesn't understand this, so it has to be transpiled back to this. And it's the same old solution. The Babel tool will do that for us. So kind of what it means is we can still write in our Mocha tests, we can write import statements like this in 99% of cases. But we just need to tell Mocha, make sure you transpile all of the code before you start actually executing the tests. And that's a simple little configuration, which we will see in the labs. The same is happening, as I keep saying, the same is happening in the web API development that Frank is doing with you. In the web API code that Frank has given you and that you are developing, you are using import statements, but behind the scenes, I think you're using Babel as well with NodeMon. Behind the scenes, when you run your web API, it's actually transpiling these imports back into these old style common JS import statements. So I'm just making you kind of aware of that. And again, I just touch on it in the lab. Okay, that was pretty quick, I know, but I think a lot of it is familiar to us, the whole kind of notion of testing and expectations and Mocha and the testing principles, all of that we're kind of fully au fait with now. So the only new aspect was the SuperTest library. And of course, the whole kind of asynchronous nature, how we handle that in our testing code. We had to be made aware of that. Okay. But other than that, it's all what we are already familiar with. Now, in the second assignment for this module, in the second assignment for the web app dev module, I'm not sure if Frank has started talking about it or not, but effectively you will be developing a web API, or more likely you will be extending the web API that he is rolling out in the labs. And so in this module, part of the second assignment will be to write automated tests for the web API that you will develop for the web app dev module. So it's kind of similar to the first two assignments in both of these modules. And that's about it, really. Now, I am going to put a lab up on this area for next week. It's not there yet, though. Okay, that was a bit of a roller coaster, maybe, but that's as much as I want to cover today. So unusually, I'm finishing slightly early. Are there any questions, I wonder, whether it be related to just what I've been talking about, or I don't know, maybe the assignment that you're working on for me, or even for Frank? Well, you haven't started Frank's assignment yet, sorry. No? Okay. I don't think there's anything else I want to mention to you. So we will leave it at that for today. And as I said, I will publish the lab accompanying this topic for Monday. All right, so I'll see you next week. Bye for now.